Hi everyone and welcome back. So let's continue this chapter from the previous video. So in the previous video we were able to baseline the basic setup for the nextjs microservice. Now we will also see how you can run tests, how you can run migrations for different environments and all these things, and what other configurations do we need. So if we go to package.json, we will first validate all these scripts like npm run. We have like build command, which is going to take care of the building the whole code, creating the dist folder for us. Then we can use npm run format, which is using prettier module, and it is just doing a okay, and it is running the prettier on all TypeScript code. So if you have I mean uh, any particular file which is having empty lines and all will be removed. Okay, you can also do npm run build prod, which is just doing npm run build, and when you want to start the production you can do the start prod command. But when we deploy anything to the production, we also need to run the migration, right? So we can also attach something like npm run db migration run and then execute this. Okay, db migration run is TypeORM migration run. So now this can be the command which I can use for the production. Start prod, it will first run the migration, right? TypeORM migration. It will see in the migration folder, do we have any pending migration? No migration is pending. Then it will start our application using dist main.js file. It's like you are running a compile, you are running the Node.js process on the compiled output of TypeScript. Okay, now we already have a setup of Docker, we are running everything. Now another important part is executing the test cases. Okay, Jest is providing all the things. Earlier we were using nyc and mocha, Istanbul, nyc, mocha, and all the test coverage libraries. Here, when you are running the test cases, obviously you need to target to a different database, test database, not the original database. So how you can populate the new runtime configurations? For that we are using .env CLI module, and with the help of .env CLI module you can pass the different runtime configurations for these npm scripts. Like if I do npm run test, it should be using this env test configuration. Like if you are passing the database URL from the env.txt, then it is going to take the configuration from there. Like when you are running the end-to-end test using Jest, then this thing can be useful, because in the end-to-end test you will be actually hitting the API and executing the test case. So here I can say is npm run test e2e. So this is end-to-end test. I haven't executed these tests, so these might be failing or passing, I don't know. But this is how you will be passing the different database environment for running the end-to-end test cases. Okay, now this is the important part, how we are using .env CLI, and in the application we are using .env to populate the process environment variable from the .env or .env example. So you can see .env is there, .env.testing you should keep. From .env we are reading and we are populating these environment variables in our application. Like in the DB, we should have one config service. Currently those folders are not created. I just created a dummy folder structure. Now basic setup is done. We have a Docker, we have Docker compose YML, Docker compose override, Docker file, and we are running the Postgres container successfully. And we are able to connect to that database also. We have this node mode to run and watch all the changes happening in the TypeScript files. ORM config, which is required for the TypeORM to define where the entities are, where the migrations are, and everything. And then we have ts config, which is a TypeScript compiler configuration. It should include only these folders while compiling, like src and test folder. That's why in the dist you can see src and test, right? And output directory is this, target is this. all the TypeScript compiler options, declarations, metadata decorators, all the script lib checks. You can actually use n number of parameters here based on the documentation. Okay, now we have a linter setup, we have the prettier setup, we have the test setup, we have the basic build setup. Okay, I mean even the production build setup, you can actually deploy this application to the production. Okay, and we are going to use Heroku for deploying this application, right? So in Heroku, what you need a proc file. So we will talk about this, what this proc file does. This proc file will tell Heroku to run this particular script when you are executing, when you are deploying this application, because we need to run the migration and then we need to run this production start. Okay, what other configurations are, like we have environment, we have a Docker. We don't need to do anything because earlier we were doing a lot of configurations and all for the NYC, and for the code coverage, for the Mocha configurations and all. Everything is now being managed by Jest. That is really awesome. You can even do the coverage. npm run test COV, and Mocha provides a lot of additional features. Sorry, Jest provides a lot of additional features, like when it comes to the mocking and all these things. This Jest is a test runners, and which is providing everything whatever we need. We don't need to be dependent on any other library for doing it. Jest is something which is being used across all different frameworks: React, Angular, Node.js, Express, nextjs. Everywhere the Jest is being used. Okay, so it is just running the coverage. We should be able to get the coverage, and the rest all the scripts are TypeORM, right? Because we are doing the npm run migration run, npm run migration generate, npm run db revert. It can be db for the consistency. We can just do npm run db migration revert. Okay, npm run db sync, npm run db migration generate, db migration drop. You can see it also generated a coverage for you. So this is like a win-win situation. You don't need to be dependent on all lot of modules, NYC, Istanbul, Mocha and all, Mocha, Chai and some assertions libraries. Everything this just is providing you. And these TypeORMs, you can also try some of these commands like npm run db migration generate, and you just put the file name, which migration file you wanted to generate. So it will check, and it will, you can see in the migration folder it has generated this file. db migration revert, I mean whatever the last migration you executed, it can be used to revert that. So db migration revert. This command is also useful when there is some error in the migration, you wanted to revert it. So from the migration table, it will remove that particular row. So you should be able to execute that migration again. Currently, this is in the source code, but not in the migration, so it will give an error. Now, migration sync and all these commands, db sync command we use when you already have the entities and you wanted to generate the tables out of it. So it's like it can be used only in the development environment. Migration run, when you wanted to run migrations in, so this argument -t each is really helpful and important, because TypeORM migrations run in a single transaction, but what we want is we wanted to run each and every migration as a transaction. So if one of the migration fails, it should not impact the previous migrations. Okay, so these are the migration scripts, these are the test scripts, and these are the linter scripts: npm run format, lint, and this is the build and deploy scripts. Okay, so things are very clear. We know each and every command which we are using. .env, CLI, Postgres, and dev dependencies, TypeORM, nextjs TypeORM, all these scripts we are using. Now what we are going to do in this baseline is we are going to introduce TypeORM. Currently those modules are not there. We will also write a DB module, config module, auth module in the nextjs so that we can start writing the code. Now the basic setup is done, deployment setup is done. We also need to introduce one CI/YML, like if you are using GitHub Actions or GitLab CI/YML for CI/CD. Otherwise the application is done. Now we can start consuming the database connections and all. For that, what we can do is we can introduce our package npm install. This is there are two packages we need, TypeORM and TypeORM. So these modules will enable the TypeORM in the nextjs, and then we will write a database module which will read all the entities. We will create a folder structure, src app. You can see domain. Inside domain we can have entities, services, controllers, DTOs. These are building blocks of nextjs. You will be writing controllers, defining all the routes, services which are going to access to the repositories. Domain modules, you put everything, you put all the declarations of your controller, services, and everything inside domain module. Import the domain module in the app module. Okay, and we can have auth modules, database module, logger module. All these things we are going to add in the src. So I think we already have a logger module, database module. Okay, now next video is, let's write the code, put some controllers, some services, and expose an API through the Swagger, because Nextjs is giving the support of the Swagger. You don't need to do anything out of the box. You can just configure the Swagger stuff and you write your Swagger configurations and all and import that in the main.ts. Okay, now to build the microservice, this is the basic setup. Now we are introducing the code. So code level security, what all security modules you need, how to write your routes, how to write your services, what all things you need to take care, how to write the config module to provide the configuration to your whole application, how to write database module, how to write a logger which can interface to the external library or external interface to aggregate the logs, right? All those things are important now. Let's check that out in the next video. Hi everyone and welcome back. So we are doing the baseline setup for the Nextjs microservice, and we have done all different kind of configuration. Now it's time to write some code. Okay, so once you generate the application through Nest CLI, you will get some default controller, default module, and one particular service and some default test cases for it. And this is your main.ts, which is bootstrapping your application through app module. So this is your app module. One is a root module. It is having only one controller and one service. Now where should we write the rest of the code? You can define your own folder structure and all, but I will give you some specifications, like this is how you can follow it. You can create app folder inside src, and inside domain you can keep all your controllers, services. All the controllers will go here, all the services will go here, and you can create one domain modules. So here you can also make it plural, like domains. Inside that you can have a project, cart, items, all these things, something like this. You can make it plural like domains, and then you can put, okay, I have item, and then put all the controllers, services, factories of the items here. Similarly, create another folder, put there its own controller, factories, and services, but there will be too many folders, right? So what I did is, let's say, create a domain. Inside that, put all your services, controllers, and DTOs, interface, everything here, and export that inside one common domain module. Auth module, if you are using some kind of authentication authorization. Database module, which we need to connect to the database, logger, migrations which are getting generated, and the entities like database entities. We have already provided this path in the ORM config, app domain entities. If you see dist app domain entities, we'll put all our database entities here. So entities like user, product, cart, items, contacts, any kind of database or entities which we are going to create a table. Okay, So these are called as simple entities. And how we are going to create them? So what we can simply do is we can start with the simple folder structure, like this is the app module, and inside domain we can start creating the controller services and all these things. So let's say we have one simple entity we wanted to create, so we will also create other migration for it. So what we can do is here we have to create a migration command. Migration command, we already know what is that. And we also need to set up all the other things like the DB module, the config module. Config module is all about, let me just create this. Config module is on us if you wanted to introduce this in the application. What config module will do is it will take care of populating the configurations from the process.env. Okay. Now what we are planning to do is let's create a Swagger. So inside Swagger we already have folder how to introduce the Swagger module. So we just need to introduce the Swagger config and swagger.ts. I will come to the code what we are writing here. Okay, so this is my Swagger and we want to expose all my APIs through the Swagger interface, right? So this is my swagger.ts. What I'm doing here is I'm just specifying, okay, what all tags I need, and this is my Swagger config, which is okay, nextjs templates, all the default tags, Swagger interface, and it is exposing one method, create a document. This create document we are going to call from main.ts, so that after application bootstraps we should be able to instantiate Swagger. Okay, so go to main.ts, and what we are doing is Swagger module.setup API v1 will expose the Swagger, and create document we are getting from the Swagger. Okay, so we will just import that, create document from Swagger, and then Swagger module we need to import from the nextjs Swagger. This is the basic setup we need for the Swagger. Okay, then app is listening through this, or if it is not provided, then we first of all we will look into the process.env. Otherwise we will start on 3000 port and our application will start running here. Okay, so this is how we will set up Swagger. Now the rest, all the things like Swagger tags and all, you need to configure in your DTOs, controllers and all, so that this Swagger module can expose that. For Swagger module you need two different packages, Swagger nextjs Swagger, and I think one is Swagger UI Express. Let me just get that. So these two modules we need for introducing Swagger in the application. Okay, so Swagger module is done. Similarly, we will not do a heavy lifting things like adding a logger and all. Configuration module, you may or may not need. Configuration is nothing but populating the things from the process.env to your application. So either you can use simply .env module. What .env module does is it actually populates everything from your .env file to your process.env variable, something like this. Right now, whatever you are specifying inside .env file, I can access using process.env.node.env, process.env.database URL, or to make it more consistent, you can write a config service and define, okay, these are all our configs I want. This is like Azure config, AWS config, Kafka config, or the Node.js environment config. We can manage that. Or nextjs also provides config service that will help you to validate the parameters. Okay, the port should be of type number, the username, database username, and URL should be of type string, all these things. Okay, now important part is the DB module we are going to configure. So because it's an independent module, so we are going to create a db.module.ts, db.service, db.interface and db.logger. Let's say for now db.module is enough. Now what we are going to say in the db module, if you look into how nextjs connects to Postgres through the TypeORM, it's very easy. What it does is it just need a connection URL. You pass the connection URL and that's it. This is just a connection options which is taking. So what we are going to do is we will write this configuration. I have already covered all these things like basic setup of how to create database module, how to create a logger module, how to create a swagger and all. I'm just repeating it, but if you want to look into depth, okay, how all these things are configured, you can check out the previous playlists. So this db module is nothing but what we want is if you just go and check this out. So how we are connecting here, if you see, we can just create a database module, something simple like this. Okay, TypeORM module we already have from the nextjs TypeORM, pass all the configuration, that's it, it's done. And then typeorm.module.forRoot, wherever you wanted to use the tables, this is how you will do it. And this is how you are defining the entities, TypeORM entities like user, product, cart. You will use all these annotations to define the entities, and then you will run the operations. Here we are connecting to the MySQL. Here I'm passing all the entities. Here you need to pass all the entities you have in the system when you are bootstrapping the TypeORM module. So TypeORM knows, okay, in the whole system these are all the entities are. Synchronized true means you can do the reverse engineering from entities to the tables. But in the development, in the production, we don't need to enable this flag. Database user, you can also pass a simple URL instead of passing the 4 variables, connection URL of MySQL, connection URL of the Postgres. Okay, and when you wanted to use any particular table in a particular module, let's say there is a user module. So you have to initialize, you have to provide that user entity to that module so that this user service can access the user repository. Okay, this is the additional thing which you will see in the documentation of the TypeORM, how it works. And then inside a service, what I'm doing is user repository dot find, find one, find all, delete, update, all these operations I'm able to perform. And we are going to manage all the relationships between these entities using one-to-one, one-to-many, many-to-many, many-to-one, using all these annotations, one-to-one, many-to-one, many-to-one, many-to-many, one-to-many. Okay. So I mean, this is it. Like what I will do is we will create a simple database module, config module. We can skip, we can actually use the configurations from the process.env.connection URL, process.env.node.env. That is enough. Okay, I mean, what is the minimal microservice setup we want in the nextjs? Rest you can expand it to any particular level. We don't need what is the minimum security, what is the minimum setup you need for microservice. Then we will build on top of that. Okay, thanks everyone. Let's see the rest of the setup in the next video, and then we will start building, like we will start talking about the 12 factor principles one by one in maybe 1 or 2 videos. Thanks everyone. Hi everyone and welcome back. So in this video we are going to do the CRUD operation for our microservice, and we'll also understand how we are managing the database connection. Okay, as we have already seen in the documentation, we are using TypeORM module. What all it needs is it is calling forRoot method and we are passing all the arguments. This is one way to initialize the database connection. You have to pass all your entities. So what we did is, okay, whatever is starting with the entity.ts, take all those entities as input. This is the one way of initializing a TypeORM module with all the database credentials. This is from the documentation. Okay, what we did is we have written the same thing. If you see our database module, so here it is db module, database module.ts. Here we are doing the same thing, but here we are doing a dynamic initialization of a nextjs module, TypeORM module.forRoot async. Here we are using forRoot, so there is a major difference. Here it is static initialization, you are passing all those things, and here we are doing dynamic initialization, and I am passing those runtime configuration through the another config service. So it is dependent on config service and logger module, and from the config service only I'm getting the database URL. Okay, SSL, like for Heroku we need SSL enabled. For local environment we can keep SSL false. Okay, this is just a check I need to add for the Heroku. Otherwise on the local environment you can always keep SSL false. This is the database connection URL, and the type is a Postgres. Okay, so this is the database module, and I have already talked about this in details in my previous nextjs videos. Let's now focus on the CRUD operation. So we have all the entities. This is our module. Here we are going to call the TypeORM module, the db module.for root, and we are going to pass all our entities, and entities we are going to put inside app module entity. Now let's say if we want to create our entity, we are going to create a simple CRUD operations quickly. So what we are going to do is, inside entity I'm going to create not.entity.ts, and we will also add the migration for this. So this is simple note ID, text is completed, right? Simple columns, and export default note. Okay, so this is my TypeORM entity I have created. The table name is a notes, and for this we also need to create the migration. So for migration what we can do is npm run db migration. I think this was the command, and what we will do is we will put the migration for this. And migration is simple, like what we are doing in the migration is putting what you want to create, right? The column structure, the tables and all. So we should have something in the migrations now. So we can remove all these, we don't need. And now we have our test migration. We can replace it with the table name. So the table name we are creating is notes, right? And I'm just giving you a simple example how we do it. How to execute query using migration. So we are using TypeORM migration APIs. So what we are doing is we are creating the notes table, and it is a ID, text is completed, constraint is a primary key, created at and updated at. Okay, just remove this. That is just a simple example I wanted to put. And in the down query, because here if we are not able to create a table, we have to drop it. Drop table notes. Cool. So here we are creating it, here we are doing is sometimes the UUID it is not able to execute this function, so we have to create this extension for the Postgres, and here we are creating ID, text is completed. These are the three columns. So if we go to our entity, ID, text is completed boolean, text is string, and we have created that column. And updated at. So these are the two columns, additional columns we have. So this is our entity representation, and for the same this is the migration. So if I want to execute this migration successfully, what I will do is I will check I don't have this table already created and all, and let's give a proper name to this migration notes, and this is the timestamp. This is very important because the migrations are executed in the order of the timestamp. So you always create a new migration and then rename it and then execute it. Okay, first we will do is npm run build, so that we can the created migrations can be built, and we will have this migration available in the dist folder. Okay, so after adding the entity, now we can add the controller services and all. So I will quickly add them because it's nothing fancy. Controller we are adding inside this, module, and controller will be node.controller.ts, and this controller will have a simple CRUD operations, get, put, post, I mean before the nodes entity. And now we will create a node service. Node service is going to access the nodes repo. So here we will create a node service.ts. Because these are very basic and I have covered these many times, so I don't want to invest much time in like explaining all these things. Right, we need to introduce Lourdes. Let's add the typing for it. Okay, node entity which we need to get from one folder above inside an entity. Okay, and then we have a DTOs, we will get that once we create them, so we can import them here. Okay, so let's create DTOs. So we have two DTOs needs to be created, and we'll just copy and paste them. It's like create node, update node, very basic, nothing fancy. Create node will have the class, node class for creating the new node. You can see this is the create node, and you can just add public text. This is update node when you wanted to change the status of a particular node. Okay, and we have, so both these DTOs we have created. Close all, and now let's import these DTOs properly everywhere. So create node DTO and update node DTO. We are going outside this, and then only you can get this. We will get from services folder. Okay, the build errors are resolved in the controller. Now let's go to service. Here we are getting entity. This we can import manually, and then update node DTO we can import. Looks like everything is now resolved. Found node. I think here we need to put a condition if not is found. Then only we will be deleting this, because before delete we are just checking if the node is available or not. This is fine. If nothing is there, then return null or not found exception, whatever you think of. This is our controller. Now go to our entity module, like all the controller services will be defined inside this. So we are getting service. Service should be export default. Okay, not service. Entity should also be export default. And here inside entity module, we got all the entity from entities folder, from the entities folder, and from the services folder. It is services. Okay, we got all the entities, we got all the services. We just need to add a controller. So what is the controller name? Is it is complaining because it's not a, it's a default export. So we will get it like this, and controller is a nodes. So we can also put it as API v1 nodes, and this is a nodes controller. Add that into the entity module. That's it. Now this domain module will be imported inside app module, so that we can have the whole application running together. We go to our app module. So here we can just add the domain module, and for the domain module I think we have to add a DB modules. Okay, this is already added, so we don't need to worry about it. Now we'll just do npm run build. So just like a basic CRUD, I wrote a controller, I wrote a service, I wrote a simple DTOs, and I'm not doing any kind of a request response validation, using class validator or a class transformer, right? I simply return a service. One simple entity is we have already created a migration for this. Okay, and this is a simple controller having basic get, put, post methods. The root route is API v1 nodes, then there is a post, then there is a get, and then there is a get by ID, and then there is an update patch by ID, and then delete by ID. Okay, so now we can start the application because now we are able to build it successfully, so we can start this. Before that, we have the entity which is nodes, so we also need to take care of the migration. So this is the nodes migration we have. It is creating the nodes table with ID text is completed. So let's check the details and all if everything is correct. Inside the modules, nodes controller and the DTO. Inside create we are passing only text. Inside update we are passing text and it's completed. Inside service what we are doing is, and we are saving it, so looks like things are good. Here it should be ID because not there is nothing like note ID column. Here it is again, ID should be of note ID. Okay, looks like things are good. Now we can start the application, and we did npm run start debug. It is using node it through the node, so whenever we are changing the file, it is actually restarting the application. Okay, so this is our entity, this is our DTOs, and this is our controller. A simple controller we have created. Now let's wait for the restart to happen, and then we will see our APIs. Okay, everything is good. It is available on 3000. So these are our APIs, and when I'm trying to get the node, it is saying internal server error. That means that the table doesn't exist. So what we need to do is we need to run the migration, right? That is the only missing piece here. Npm run db migration run. What it will do is, okay, let's go to the correct folder first. DB migration run will run the migrations which are kept inside this folder, this src migrations, and we have nodes. You can see one table is created with ID text is completed. This is what we needed. Now we should be able to execute this command. And now what is the problem? Let's see, because I changed something. Column not.is completed does not found. That is correct because I changed it to is underscore completed. So this is get all nodes. Let's go to the controller and we will just simply fix this. It's not a big problem. So this is our controller. Controller is doing get all nodes, and inside node service it is doing find all nodes. Find many options. Okay, let's see, is completed where it is there, because I have changed it. This survey is completed. Let's see what we have added in the table. Based on that, we will put the column. So we will check the migration first because I want to keep all the columns with underscore. So go to entity and we will just change it to is completed, which is of type boolean. So ID text is completed, and go to our migration again, is completed of type boolean, not null. Okay, things are good now. Now we can run this and we can see all the output. We can also should be able to create a new node. So this is the basic setup of a simple CRUD operation for your simple microservice. Now we will also be able to add the end-to-end test cases for the nodes APIs, unit test cases for the service, unit test cases for the controllers. So we will have a foolproof microservice. We will add the health check, logging and all these things using logging middleware, and we will be adding the security like token based security using authentication middleware, auth middleware for the protected routes. Okay, so let's see all that thing with the testing and with running all these APIs. These APIs are fine. We just need to take care of the column names, right? Like the column mismatch will trigger and the query will fail. So ID text is completed. Now we are getting everything correct. Now you can also create the new tags using post API, and we will also enable the Swagger annotations in the DTO so that you will also see what all payload you need in the request body. That we will enable in the DTOs. I mean, this is very basic. We are doing it since a long time. Like you use a class validator and API property, so that these properties request or query parameter attributes should be visible in the Swagger documentation also, which you see here. Okay,